Now let's understand MVCC with the help of a demo. I connect to PSQL and I log into the ERP database. I need to set auto commit off to demonstrate this. We create a table called EMP. Don't worry about the auto vacuum off. We will look at it in the next chapter called vacuum. Now insert a couple of rows. And then select star from EMP. If you recollect in the previous section, I mentioned MVCC is handled in Postgres via transaction IDs. So now let me find out the current transaction ID. This is our current transaction ID. Every table has a couple of hidden columns, and in order to access it, we have to explicitly mention those column names. So these are the hidden columns, that is the CTID, Xmin and the Xmax. CTID represents the physical location of the row within its table. That is, it represents the block number and the offset of that block. Xmin is the transaction ID which created this row. If you see, this is the same transaction ID which we saw above. All of them have the same transaction ID because it was all done in a single transaction. Now coming to Xmax, if Xmax is 0, it means that it is the most updated version of the row. If it is not 0, then it means that there is another transaction which is updating this row, and that non-zero number in the Xmax is the transaction ID of the session making that change. So now I have opened another terminal. Note that I have changed the color to distinguish easily between the two sessions. Let's call the terminal in black font as session 1 and the red font as session 2. Session 1 is where I had created the table and done the insert. Let me connect to the ERP database and do a select star from EMP. It does not find any relation because I have not yet issued a commit from the session 1. If you see, I had the auto commit off. After I did a create table, I inserted, but I did not issue a commit yet. So I do a commit. Let me go back to the session 2. And now I see the table and the rows. The same information is displayed on both the sessions, that is the session 1 and session 2, because now there are no more active transactions. Now the transaction number advances to 453540. Earlier, it ended with 539, and now it is 540 after the commit, and give an update of one of the rows. So earlier this row was a junior trainee and salary 1500. Now it is trainee and the salary is 1700. Now let's run this query again. We see the Xmin is now 43540. The other session should still see the old transaction ID because I have not yet issued a commit from the session 1. Since I ran this query from the same session I ran the update, the Xmax is 0. Now let me run this query from the session 2. We see that the Xmax now shows the transaction ID of the session 1, that is ending with 540. It is no longer 0 for the session 2. Xmin still shows the older transaction ID. Also, if you notice, the Xmax is still 0 for the first two rows, which means that for the first two rows, the data is still the most updated version. We see that this session still sees Adam as a junior trainee and the older salary. Now let me go back to the session 1 and issue a commit. Now let me go back to the session 2 and reissue the select. We see the updated row. The Xmax now shows 0. The Xmin now shows 435540. Let's look at the CTID, that is the block number and offset. Block number 0 with offset 3 had the older version of the row. When the row got updated, the new updated row was inserted into CTID 0,4. So what happens to the CTID 0,3? It is marked as a dead tuple. It is the job of the vacuum to clean it up and put it back to the free space. So to summarize, from the session 1, the Xmin showed the new transaction ID and Xmax showed 0. From the session 2, Xmin showed the old transaction ID, but Xmax showed the transaction ID of the session which issued the DML, that is the session 1's transaction ID. Once the session 1 issues a commit, then the transaction ID is reflected in the Xmin for all the sessions. We also saw that when a row is updated, the new row is inserted in a new CTID, and the CTID containing the old row is now a dead tuple, and it is the job of the vacuum to clean up this dead tuple. That brings us to the end of this demo.